Good morning, everyone, and thank you again to Mobile Europe for inviting me. Thanks for having me. My name is Dawid Mielnik. I lead the Telecom division at SoftwareMind. A few words about me. I've been in the industry for over 20 years now, both on the CSP side as well as on the vendor side. I have started with engineering and software development roles, then moved to pre-sales and business development. And now, for the past 10 years, I've been with SoftwareMind, where I lead the Telecom division. My responsibilities here cover projects, clients, teams, basically everything related to driving the telecom business forward. So today, I will be sharing with you the vendor's perspective of what it takes for operators to gain value from the cloud. Mm, Let me frame this presentation. It's not going to be a product presentation, but it's going to be an honest view of what we've seen that works and that doesn't across more than 2 decades of building and operating telecom platforms for operators across Europe as well as beyond. I will be covering three topics today. Uh, what it actually takes for cloud transformations to work for telecoms, how that plays differently across the public as well as the private cloud, and finally, of course, where AI is taking this whole conversation next. So let me start with who we are. SoftwareMind is a software engineering company. We are not a typical systems integrator. We're also not a vendor in the traditional sense. We operate software for telecoms. These are custom platforms, product engineering, as well as embedding engineering teams into the delivery organizations of telecom operators. We have been on the market for more than 25 years, and our telecom practice is a focused vertical within SoftwareMind that delivers services across four different areas: voice and value-added services, roaming and signaling, BSS, OSS, and customer engagement, as well as managed delivery. Our client base spans more than 50 tier one and tier two operators across Europe. We also have a growing footprint in the US and Asia as well. When it comes to our competencies, we cover end-to-end digital lifecycle, from strategy all the way to operations. Um, Cloud native platforms, platform engineering, DevOps transformations, CI/CD implementations, operations for live production platforms. We also provide product engineering for custom builds, as well as our own product suite called Amplitive that covers roaming and value-added services platforms. And now, I mentioned this not to run you through our credentials, but because our perspective today is shaped by that operational depth, by helping operators deliver cloud native platforms in production at scale. This is the perspective we also share publicly. Earlier this year, we've published a telecom playbook called Future Ready Telco. It's published here on this platform on Mobile Europe. If you have the time, I encourage you to read through it. There's a section in that playbook that is very relevant to what we are discussing here today. So the title of the event asks what telcos need to achieve with the cloud. And I would like the question to sit for a while before we move forward to actually answer it. So, according to Gartner, 85% of CSPs are increasing their investment in cloud platforms. That's a consensus. This means that money is flowing in that one direction. But also, 40% of CIOs are not meeting their CEO's expectations. It's 4 in 10. And that gap is a key number in our discussion today because it shows something which is important. CSPs are not failing to invest in the cloud. Some of them are failing to convert that investment into outcomes which are valuable to their boards and to the business units. And the question is why? I think that the main cause is something that the industry fails to say very clearly, mainly that cloud is not one thing. In treating every cloud transformation as if it was the same problem with the same solution is probably the main reason that most of the cloud programs underdeliver. Let me explain why. So when people talk about cloud transformation in industry conferences and industry briefings, the default assumption is the public cloud. AWS, GCP, Microsoft Azure. And okay, for some of the applications, especially for the IT domain, for the BSS workloads, that is probably an okay choice. But then when you look at what some of the largest European operators are doing, you see a different picture. Some of them have decided to invest heavily in their own private infrastructure. Those are usually OpenStack based platforms with a Kubernetes layer on top of that. So Kubernetes clusters that they own and operate, and on top of those, they run their workloads on. And the reason for that is not something very hard to understand. Well, you have regulation requirements around the data sovereignty. That's one. There is the concerns for latency of network adjacent workloads. You have those, total cost economics of running tier two heavy volume workloads on a public metered platform. And at the end, something which is also quite important, well, frankly, the desire to have control over the critical infrastructure. But now, this is the important part. Those operators are getting the same benefits from cloud native operations as the public clients do. They have increased the feature velocity. They have automated deployment pipelines, automated testing, automated security scans, because the benefits come from the operating model and not from the location of the infrastructure. Things like container-based infrastructure, CI/CD, infrastructure as code, a very important GitOps operating model. This is what cloud native is, and this does not require a hyperscaler. But also conversely, when lifting and shifting a big monolith application onto a public cloud without changing the architecture, without breaking up the dependencies, without implementing CI/CD, without implementing automated testing and security scanning, this is not cloud native. The infrastructure might have changed when moving it to cloud, but the outcomes probably have not. And I want to really stress this because this distinction is enormous for how we frame the success of cloud programs. The question here becomes not have we migrated to the cloud, but have we adapted the operating model to make the technology deliver? We at SoftwareMind we work at both environments, the public and the private clouds. And to make things more tangible here, I would like to give you example of two projects, but for the same operator and a different cloud approach. The first one, it's also in the playbook that we mentioned in the section entitled Optimizing Cloud Operations. Uh, the client is a major European telecom operator. It provides services, it provides telecom as well as ICT services. It is a part of one of the largest telecom groups in the world. And our project, our task, was to take over a customer value management platform, take it from the previous vendor, and complete its migration to GCP. It had a constraint. We were to maintain business service continuity throughout the project. And this is important because a lot of, if not all of the cloud migration projects in telcos, they have this constraint. And this is what makes them hard. You know, these are not greenfield projects. These are conducting live hard surgery on a running system. Mm, and so back to the project. What we obtained was, a lot of problems you would typically expect in such a situation. The project had a mono repo code structure without any clear separation of dependencies. The application code was tightly integrated into the infrastructure code. It was in the same repo. Little automated testing. The unit testing coverage was critically low. Security issues that have not been resolved. So, the platform was heading to GCP, but in a state that was no better than the platform it was supposed to replace. So a cloud destination, but far from cloud native operations. So what did we do on the project? Well, we started with a complete platform audit. We mapped every problem. We mapped the architecture. We prepared a prioritized remediation plan, which was discussed and agreed with the client before touching a single line of code. After we have agreed on the plan, we have moved to the implementation. We separated the infrastructure code from the application code. We've introduced GitLab-based CI/CD pipelines. Some of the applications were rewritten in order to meet the current standards. Unit testing coverage was raised above 80%. We introduced automated integration as well as end-to-end testing. But the security issues were removed, but also, what is important here, we added the security scanning into the CI pipeline. Business outcomes? First and most important, consistent automatic deployment across all of the environments. Reliable releases because of the automatic test coverage, faster commit to deploy, and what's important, the platform migrated to GCP with reduced deployment times for new features. And now this last one is the actual business metric, not the platform is on GCP, but the reduced deployment times for new features. This is what the business was waiting for. So what I want you to take away from this is not the technology stack. It's not the cloud destination. It's the sequencing. The value of GCP was not realized until the operating model was fixed. GCP was the destination from the beginning, but the transformation happened in the delivery practice. Now let me go to the second case. Like I said, this is the same operator. The same cloud ambition, different infrastructure approach, different cloud of choice. Um, the platform here was a corporate multi-tenant hosted virtual PBX service. So this provides services such as IVR, call queuing, recording, as well as self-care and API access for corporate clients. This is a really business critical service, and any outage has direct, severe commercial consequence. The infrastructure here was operators' own um, OpenStack based a platform with a Kubernetes as a service layer on top of that. Our situation on arrival was similar as in the previous case. CI/CD was not implemented in the extent that it was supposed to be. Automated tests were missing. They were mainly manual and prone to error. Um, the platform was not ready for the traffic that the operator wanted to route to it. What we did was similar as in the first case. So before touching any of the code, we performed a complete audit. We again mapped the architecture with the problems. We prepared a prioritized a list of remedies, which we agreed with the client before moving on to the implementation stage. At that point, we focused on three areas. First, stability to repair the performance and redundancy capabilities of the platform. For a live corporate voice platform, this is not negotiable. And then we moved on to the DevOps practices, implementing CI/CD on that private cloud. We moved the config into the Git. We automated the deployment using Ansible for the infrastructure and Argo CD for the Kubernetes layer. We introduced automated testing across the web, API, and SIP interfaces, and we implemented automated security scanning. Only after that could we move to increasing the feature velocity. We scaled the team up to 9 engineers, focused on business features such as additional multi-party call handling, recording, extending the API. Currently, the team is focusing on extending the platform's observability capabilities by integrating into the operator's Elasticsearch service. And two different projects with a different tech stack. The second one more oriented towards voice-specific middleware and deployed on a private cloud. But what is important here, and I want to stress this, is the engineering principles, which were identical. CI/CD, Git managed configs, automated pipelines, and testing. It's the same DevOps velocity and the same confidence for deployment that the operator had as in the GCP case, because the practices are the same. The cloud is private, but the operating model is cloud native. And, I've walked you through two cases, same operator, but two different cloud approaches. And I think that this is something that the industry needs to say more clearly, which is that the value of the transformation does not come from the location of the workloads. It comes from how we build, how we test, how we deploy, and how we operate them. The projects had a different cloud environment, but they had the same gap. Both existed before, both were running on some sort of a cloud infrastructure. In both cases, the operator was the gap in where the operator was and where it needed to be going was entirely in the engineering and operational practice and not in the infrastructure of choice. And Things like CI/CD, automated testing, infrastructure as code, GitOps model for operations. These are the typical table stakes for any modern software development company. But in telecoms, they're consistently missing. In telecoms, the legacy runs deep. Cloud platform stability was often chosen before operation agility. Vendor transitions and program resets are often so. This is usually the case, and mm, when operators ask what they need to achieve with the cloud, I think this is the honest answer. You need the engineering practice to match the cloud infrastructure ambition. Whether public, private, or hybrid, the practice is the same, and the gap is always in the practice. Now, I want to talk a little bit about AI because because I think that AI is actually the most important lens through which to evaluate your cloud transformation project. And again, going to Gartner, uh, the reports say that 98% of telecom operators are increasing their AI investment spending. Not 80, not the majority, 98%. At the same time, NVIDIA has tracked over 720 Gen AI projects across more than 100 telcos. And this shows one thing, that the scale of the investment in telecoms for AI is is like unlike anything we have seen since 5G. Um, um, and we say in the playbook that we published, don't AI for the sake of AI. Launch targeted solutions that are in line with the strategy and not distract from it. And I want to hold on to the principle while I walk you through what I think that AI really requires, because the ambitions are real, but so is the risk in investing without a solid foundation. And what AI needs for proper performance are three things from the infrastructure. It needs real time and accessible data. When running AI models for churn prediction, for anomaly detection, for fraud identification, you know these models are only as good as the data they're input. Uh, you need streaming data, event-driven pipelines, accessible APIs. You can't build a real-time AI service on a nightly batch exports from your SQL database. The second, it's elastic on-demand compute. The training and the inference needs of a tier one operator. It's not something that's constant. It's not a constant infrastructure problem. It's something that fluctuates. You need to scale up the resources quickly, and you need to scale them down just as fast when the work is done. Third, and this is something that often catches the operators by surprise, it's a modular, decoupled architecture. Uh, when developing a new AI-powered feature, you need to deploy the full stack of your PSS application. You're not going to be able to iterate fast enough to make the AI work. Monolith blocks AI iteration. You need microservices, API gateways, event buses for incremental development of AI features. And now, and this is where it gets interesting, the practical implications of all of this. The cloud decisions that you have made in 2022, 2023, and 2024 are directly impacting what you can do with AI in 2026 and beyond. Operators who took shortcuts, who chose speed of cloud migrations over genuine cloud native transformations, are now finding out that their AI roadmap is actually blocked by the integration debt that they thought they had escaped. And on the other side, operators who really invested in cloud native architecture redesign, who didn't take the shortcuts, they are now finding out that they are accelerating their AI initiatives. I can give you an example from our own backyard. We run and operate roaming and signaling platforms for operators that process literally millions of records daily, and we have built those platforms on event-driven architectures, on containerized applications, not for AI, but for operational flexibility, for operational resiliency. And now, when operators now ask us to implement things like anomaly detection on signaling data, fraud and identification on roaming records, the architecture to build the intelligence is already there in place. Conversely, operators who would struggle to do the same thing are the ones that took the wrong cloud decisions some 3 years ago. AI is not just another layer of telecom transformation. It's a ruthless audit of every cloud architecture decision that you have made. So now let me summarize all of this with some key takeaways for you. At first, don't let the public cloud narrative define your cloud strategy. If you have a private cloud, you can get the same cloud native operating outcomes as the public cloud clients. The hyperscaler is not a condition. Invest in the operating model to get CI/CD, infrastructure as code, automated testing working. The benefits come from those. Second, infrastructure migration is a precondition. It's not an outcome. It's important, but the transformation happens in the delivery practice. So invest in that. Assess AI readiness before your AI program starts. Talk to your team. Talk to your infrastructure, to your architecture team. Ask them, do we have streaming data? Is it accessible in real time? Do we have decoupled systems? Do we have elastic compute? If the answer is no, these are your next cloud investments and not the model selection. The last one, which is critically important, demand production references from your vendors. Not PDFs, not POCs, but references of running systems in production at scale for more than a year. Because the gap between the POC and production, this is where most of the value is lost in telecom programs. And finally, to close, I will say this. The infrastructure question is largely answered already. While, complex in execution, it's no longer critical. Hyperscalers have made the business case. Private clouds are mature already. The unanswered question is the operating model. It's how you build, how you deploy, how you test, observe, and iterate. And this is an engineering culture question just as much as it is a technology question. And it requires investment in practice, not just in the platform. So this is what we do at SoftwareMind. This is what we help operators do. And it is something I would like more people in the industry to focus on. Thank you.
David, that was really very thought-provoking. Thank you very much. I definitely am going to go back and watch that on demand a few times because there's a lot of important information, and I think some of it, as you say, is quite surprising, really. Sorry
Hmm.
to say we've only time for one super quick question. So you said that essentially AI is an audit of every cloud decision operators have already made, which is a bit scary, I think, if you're an operator. Um, do you think most operators are going to pass the audit? My suspicion is not.
Well, honestly, Annie, I think it's mixed. Yes, those who
Okay.
have really invested into the transformation that really put focus on delivering that cloud native transformation in the practice, in automation, and not just moving the infrastructure location. Like I said, I think those ones will benefit because they will get the speed and the agility required to iterate over implementing AI, and those who didn't will see the gap and will see the problems. But from my experience, a lot of these initiatives are POCs or pilots. So I think this gap will become very obvious soon. Right now, I think this is.
Okay. Dave, thank you very much indeed. That's a good session.
Thank you. Thank you very much.